So this is part 2 of our bonding summary. In part 1, we looked at ionic bonding. We looked at ionic bonding, and we looked at how ionic bonds were formed by metal ions giving electrons to non-metal ions. We looked at our examples here. We then went on to say, well, that's just one atom giving one electron to another atom to make opposite charged ions. But ions are really tiny, so we can't think about the structure as a whole by thinking about just two ions. We need to think about lots of ions. And we said ionic structures are made of ionic lattices where there's lots of positive ions attracting lots of negative ions. And these oppositely charged ions attract each other really strongly. And we just got down to talking about the melting point, and I got halfway through the melting point explanation before I ran out of time on that video. So let's just pick that up again. Okay, so the melting point of ionic substances, of all ionic substances, is very high. Why is the melting point high? Because the ionic lattice, the structure, is made of oppositely charged ions that strongly attract each other. So we've written here already the melting point is high because those strong forces of attraction between oppositely charged ions. If there are strong forces of attraction between opposite charged ions, it takes a lot of energy to separate the ions, okay, or to overcome those forces of attraction, or to break those bonds. You can say any of those things. Electrical conductivity. So this is quite complicated for ionic. And it's if you understand this, then you'll probably understand electrolysis. Now, we did about 5 videos on electrolysis, so you can watch those to your heart's content. But let's just briefly summarise here. Ionic substances can conduct electricity under some circumstances. So first off, solid ionic substances. They do not conduct electricity. Okay, to remind you, a current of electricity, should we write this on the side? We're writing lots of things on the side that are useful to us. A current of electricity. Okay, before you can say whether things conduct electricity or not, you have to know what a current of electricity is. And if you don't, then you've got no chance of understanding whether things will or will not conduct electricity. So a current of electricity is a flow of charged particles. Now, when I teach a lot of GCSE students, they tell me a current of electricity is a flow of electrons, and they're not wrong, they're just not totally right. Most things, like metals, for example, or carbon graphite, when they conduct electricity, it is electrons that are flowing, and electrons are negatively charged. Okay? But there are other charged particles. Now, I'll ask this question to a class. Just say, tell me another charged particle that could flow to make a current of electricity. And when I say that, invariably the hands go up and people go, protons. And that's not true. That's not right. Protons are locked in the nucleus. Protons really do nothing in chemistry at all, apart from give the atom its identity. So there is, of course, other charged particles, and look at them. They're just here. Positively charged ions and negatively charged ions. Positively charged ions, negatively charged ions. These are charged particles. Now, if these can flow, they will conduct electricity. But in the solid state, ionic substances do not conduct electricity. Why? Because the ions cannot move. Why can't they move? They're held in this ionic lattice by strong forces of attraction. I'm not going to write that again because I've got limited space here, but it helps if you know that, and you may want to write it on the end in the exam answer. So solid ionic substances will never conduct electricity because the ions cannot move because they're held in place by the strong forces of attraction. Liquid. Well, how can it become a liquid? Molten or dissolved. Melt it. Okay, that's going to take a lot of heat because these ions are strongly attracted. It takes a lot of energy to break these ions apart. Molten, so we can melt it, or we can dissolve it. Now, some ionic substances dissolve in water. Okay, some don't, and there are solubility rules. We'll do that in a moment. Liquid, so molten or dissolved. Yes, they do conduct. Why do they conduct when they're a liquid? Well, because when they're a liquid, the ions can move, and they move to the oppositely charged electrodes, and that's electrolysis. Yes, they do conduct because the ions, the charged atoms, the ions can move. Solubility in water, I said this a moment ago. Some do, some do not. Okay, learn solubility rules. They are in your book. I'm not going to go through them now. There's not enough space on here. Learn solubility rules. Okay, so that's ionic bonding. That's everything we need to know about ionic bonding. So that's our first type of bonding. Let's just recap. Metal giving an electron, metal giving an electron to a non-metal. Second type of bonding then, covalence. Description. Okay, well the atoms involved in this one are non-metals only. Okay, so again, if you are aware of the atoms in a compound and you don't know whether the bonding is ionic or covalent, have a look at where they are on the periodic table. If the atoms themselves are on this side here, or hydrogen at the top, hydrogen's a non-metal, that would be hydrogen there. Okay, if hydrogen's at the top there, or any over here, any of these, it will be non-metals only, and that type of bonding will be covalent. So the definition of a covalent bond is two or more non-metal atoms. Now those two or more non-metal atoms can be atoms of the same element. Two or more non-metal atoms, okay, now the important bit, okay, and this is the bit that you just have to learn. Sharing a pair or pairs of electrons. So it's a shared pair of electrons. A covalent bond is a shared pair of electrons. That's often a 2-mark answer in an exam. What's the definition of a covalent bond? Shared pair, 1 mark, of electrons, 2 marks. It gets you 2 marks for knowing that. Okay, this double page spread is so important. There's so many marks in it. Right, examples. Let's do 4 examples here. We'll do 2 foundation tier and 2 higher tier. Okay, first one. The first one we're going to do is the hydrogen molecule. Oh, next thing to say, molecule. Okay, molecule. A molecule is, we only use the word molecule when talking about covalent substances. A molecule is a particle where the atoms are bonded covalently. So non-metal atoms, we can put that in there. Atoms, let's put that in there. Non-metals. Can't have a molecule with a metal in it. Okay? So often I hear people use the word molecule to describe covalent substances, and that's, you know, to a chemist, that's like seeing a dog walk by the window and then saying, oh, look at that lovely cat. They're just completely different things. Okay, molecule is for covalent only. So, first one, the hydrogen molecule, H2. Then let's talk about maybe the methane molecule, CH4. Notice, carbon, hydrogen, both non-metals. In this example here, we've got 2 atoms of the same element, hydrogen, and this leads us to diatomic molecules. Diatomic means a molecule made of 2 of the same atoms. Okay, so we've got hydrogen. Hydrogen has got an atomic number of 1, so that means it's got 1 electron. Let's do it there, cross. So I've got a dot for the nucleus, first shell, 1 electron on it. Right, now all atoms want a full outer shell of electrons, and that's why they bond together. So that's not got a full outer shell of electrons, it's not happy. What's it going to bond to? We're told the molecule is made of 2 hydrogen atoms, so I need a second hydrogen atom. And what we know is a covalent bond is a shared pair of electrons. So to share that electron, this pair of electrons, we have to draw the next atom very close to it, there's its nucleus, and we're going to draw its outer electron shell, overlapping the first one. It's going to overlap the first one's electron because it's a shared pair of electrons. Now this hydrogen here also has an electron. And I'm going to do this electron as a dot, and I'm going to put it in the overlap there. So what we have there is the covalent bond, the shared pair of electrons. Okay, covalent bond, shared pair of electrons. And that is a simple H2 molecule. Okay, sometimes you'll see that drawn like this. Okay, 1 hydrogen bonding to another. The bond is the line where we can see the bond is a shared pair of electrons. Let's put the electrons on there. There you go. So that's a hydrogen molecule, an H2 molecule. So it could be written like that, so drawn like that, or maybe drawn like this. Okay, but that is the dot and cross diagram we're after. Dot and cross, why do we do that? Chemists like to be able to see exactly where the electrons come from. So those electrons are identical. We just draw the electrons of one atom as a dot and the other atom as a cross, and there we can see where they come from. CH4. This molecule now has 1 carbon and 4 hydrogens. Well, we need to look for the atomic numbers. They're found on the periodic table. The atomic number of carbon is 6, and the atomic number of hydrogen is 1. Now, when doing these, let's draw the atom that is there least first. So the atom that is there least is carbon. Carbon has got 6 electrons. So dot for the nucleus. First shell holds 2 electrons. Sometimes you're told to draw the outer electrons only. If that's the case, then you don't need to draw the first shell, but you do need to remember that it holds 2 electrons. Second shell. Well, the second shell is going to be the outer shell, so if you were told to draw the outer shell, you'd just draw this second shell, and the outer shell would have 4 electrons on it. 1, 2, 3, 4. Well, this atom needs 4 electrons to fill its outer shell. So if it needs 4 electrons to fill its outer shell, it must form 4 covalent bonds. Okay, and a covalent bond is a shared pair of electrons. Now we've got 4 hydrogens, so we're going to need to draw a hydrogen around each of these electrons. So there's our first hydrogen. I've not really done it very centrally, have I? Its electron, let's put it in the overlap. So there is our first covalent bond. So this carbon now has got 1, 2, 3, 4, 5 electrons on its outer shell. And it's got that extra one by sharing a pair of electrons here. So next hydrogen, there. Let's draw it over that electron, and let's put this hydrogen's electron in the overlap as well. And same with this one. And the same with this one. There we go. And there is our methane molecule, and that looks a bit like this, I suppose. C bonded to 4 hydrogens, and you see it drawn like this all the time. This is the dot and cross picture, and this is just that abbreviated. Each of these bonds, each of these lines is a covalent bond, a shared pair of electrons. Next example we're going to do is going to be oxygen, the oxygen molecule, like the hydrogen molecule, but the oxygen. Oxygen has got 8 electrons. So 2 on the first shell, and 6 on the second shell. Well, if it's got 6 on the second shell, it's going to need 2 electrons to fill its outer shell, if we're happy with that. Okay, so it's going to need 2 electrons. So instead of sharing 1 pair like hydrogen, it's going to share 2 pairs. It needs 2 electrons to fill its outer shell, so it's going to form 2 bonds, so it's going to have to share 2 pairs. So let's draw the outer shell of another oxygen overlapping those 2 there. There's its inner shell. So it's got 2 electrons on the first shell, oxygen, and 6 on the second. Well, it's going to share 2 pairs. So 2 of those 6 on the second shell is going to have to go in the overlap. So that's 1, 2, 3, 4, 5, 6, and those 2 on the inner shell there makes 7, 8, 8. So now the important thing to do now is count these at the end to check they're right. So count the outer shell of every atom. 1, 2, 3, 4, 5, 6, 7, 8. That one's okay. This one here. 1, 2, 3, 4, 5, 6, 7, 8. That one's okay. Now the last example, the hardest of all, carbon dioxide. Carbon dioxide, CO2. Atomic numbers, carbon 6, oxygen 8. Okay, we'll draw the one that's there least first, carbon. Dot for the nucleus. 2 electrons on the first shell, so uses dots. It doesn't matter whether you do them dots or crosses. Okay, and there's 2 on the second shell. It's 4 in total on the second shell. 3, 4. It's got 4 on the second shell, 4 on the outer shell, so it's going to need 4 bonds. There's 2 oxygen atoms, so it's going to need, this carbon is going to need to form 2 bonds with each oxygen atom to get 4 in total. Let's draw it out and see if you can understand it. So I'm going to draw the outer shell of an oxygen here, overlapping 2 electrons. Overlapping 2 electrons. There it is. And let's put the oxygen's 8 electrons in. So 2 on the first shell. It's going to have 2 sharing in that carbon there. So that's 3, 4, 5, 6, 7, 8. And the same on this one. Let's draw the outer shell of another oxygen over those 2 of that carbon. And 2 crosses on the first shell, 8 in total. 2 in the overlap, 3, 4, 5, 6, 7, 8.